Now, I just want you to be looking at and describing a relationship between two variables. So that could be two categorical variables. We learned how to represent that data. You could look at probabilities, things like that with that data. You could look at some quantitative variable across two different populations, because you could then treat that as one quantitative variable against two different, or against a categorical of sorts if you create two dot plots or two histograms, whatever else, okay? And so you're going to need to come up with a project that you legitimately think is interesting. The reason why I say that is there's been projects I've had that were legitimately interesting, or I won't say that. There were projects I've had that people submitted just to do something rather than actually investigate the world around them. An example that comes to mind is the first year I was at Hillcrest. Eli did a project on what the age was of people who went to the YMCA gym at what time. So he looked at the correlation of ages and time attending the gym. That's fine, I guess. And I guess if that's interesting to him, that's interesting to him. But
I thought it was interesting.
I thought it was boring.
Really? It makes sense though. Older people go earlier.
And so I will say this: to me, it wasn't that boring. It wasn't that interesting. He was able to make that case because it was interesting to him, because that's where he worked out. Okay. And so I want it to be something though, and so that's my point. That to me wasn't the most exciting thing, but it was relevant to him, and so it impacted the way that he saw the world that he lived in. And so I want you as a group to come up with, and you need to defend it. Now, what I will say is this, and I should have pushed back on this. One example of a study that I had last year that I was wary of it being interesting, and then the data didn't end up being interesting, was the rate at which somebody's dog chased after a red tennis ball versus a yellow tennis ball, and I was just like,
They're colorblind or something.
no,
Yeah,
just
I don't think dogs can see red.
Yeah.
Wait,
I don't remember. I don't know exactly all the stuff with.
It's
Regardless,
Yellow, colorblind.
So,
they can't see to it.
anyways, it didn't get super interesting, right? So I want y'all to come up with a project together. So make sure before you leave class today, you exchange contact information, phone numbers, group me's, I don't care, whatever you want to do to talk with each other. Discord if you're Jaden, because he's all like, ooh, I'm Jaden now. And Brayden, sorry.
Well, that doesn't even mean.
Wait, what?
Oh, sorry. Is that the cool thing? Is that the cool way to get it?
No, it's because it's on repeater, so you can it's easier.
I'm just giving him a hard time. It's because of this weekend.
He's
I
a Discord
was
bot.
like, oh, I have Stanley's Discord. I'm like, you can't just text the dude? Alright.
Say
Anyway.
Discord one more time in this class and then click out.
Alright, so,
Discord.
what I want though is this. So, when are we presenting our projects? Next Friday, okay? For you to have enough time to be able to get that project done, collect that data, I would like to see your proposals this Friday, and because I can look at 3 proposals in a night, and I can email the group to either say go for it or not. But it does not have to be you don't have to collect the data here. It could be an observational study, it could be an experiment, it could be a survey. You just have to look at least how many variables. 2. Okay? I want to see a correlation or some kind of relationship between 2 variables. Make sense?
Yeah.
Okay. Go for
Do
it.
we have to collect the data in real life, or can we just look up stuff?
I just need to see 2 variables. So, when he says collect the data in real life, now I will say this, if you're going to do an experiment, yes. But what type of study could you conduct that would allow you to see data from the past? Yeah, so there's a special name, retrospective study, right? So you could 100% do a retrospective study. Well, prospective and retrospective observational studies.
I've never heard of those until I looked
No,
up
we did
progress
talk about
thing.
it. We
I was
talked
like,
about
what the freak?
perspective and
What?
Yeah, we did. Yeah, it was in one of the Skew the Script lessons. Yes, I promise you. We did. So, yes, you can do a retrospective study where you go and collect data, and I can give you pointers on maybe where to find some of that data. Totally valid. So that's why I say, like, it is really open to you for you to collect data in a valid way. What I will make a note of is this though, if you're going to collect data that has already been collected, I still need something from you to show how you reduced the effects of bias, did some type of random sampling with that data.
Us specifically, or the like data
You.
person?
Because I want to see that you do it well.
What if you just
So we can talk about how we can make that work if that's what you end up deciding as a group. Yes, David?
what if you just like clean it?
We can talk about that as well, but I do want to see you actually conduct some stuff. But for example, I'll say this, like, there are some resources out there that I can highly recommend. There's one called Census at School, where Census at School actually has thousands upon thousands upon thousands of pieces of data that are collected from students where they fill out surveys and they put that data into Census at School to be used for stuff like this. You can also use, and I can show you how to use it, but there's the Alabama State Report Cards. You can look at the Alabama State Report Cards to see maybe how socioeconomic status correlates to the state report card or ACT scores, and so I can show you how to collect data like that about education. So there are a few things that I can go ahead and show you, hey, if you're interested in something with education, here's a place where you can go and collect the data yourself. I don't want you to just rely on someone else's study. I want you to collect the data in some way, okay? Last things I want to make a note of on this, it does say poster on here, but I did make the note that you can do a PowerPoint as well.
Can we do both a PowerPoint and a poster and the extra?
Honestly,
Oh,
I'm
my
down
crap
for
over
that.
there.
On the back side is a rubric, indicating what I am looking for. So please make sure that you are considering those things. Wait, why are you taking those?
I never got one. Oh my.
There's three
Three now.
right there. I got you.
I understand.
Okay. So please make sure you look over that, see if there are any questions that you have before tomorrow so you can ask those questions, but work with each other to grow and get better at these statistical ideas. This is once again another way for you to show evidence of mastery of the concepts that we have in statistics. And so your ability to engage and talk about this and explain what you did and why you did it during the presentation can go towards your evidence of understanding on the proficiency scales. So keep that in mind. We will have, I was planning on having our next AP free response review question Thursday. We'll figure out how that's going to go. I have decided we are going to go over this progress check to start class on Thursdays. So for those of y'all who are going to be late, you will miss less new material.
Thursday, we're having.
Yeah, we're not from this
The
week.
whole day is e-learning.
You're right.
Thank God.
What's going on?
Bro's gonna record it.
What?
Yeah, I'm going to come up with something.
Oh, nice.
Nice.
That's not good.
Oh.
That's what I get.
He's gonna record it.
No, I'm gonna figure out
He's
something.
gonna live stream it.
Not gonna live
Yeah,
stream it.
Live stream it and then you text the chat and you
Definitely
reply to the
thought
chat.
that.
Yeah.
Wait, you
And then we
can
take
take donations.
Wait, what's going
Yeah.
on?
Alright. Well, that means we are going to be sprinting today. Thanks for that reminder. So, we talked about the project. We're getting into random variables today. So you have the proficiency scales and the Frere models for this section. You did not give me your Frere models for this most recent DYU. You need to. So the proficiency scales are there though. Don't worry about the formula sheet. I'll explain what that formula sheet is in a few minutes, or we'll get to it throughout this unit. Trying to remember if there's anything else. I don't think so. So that's what we just did completely. I meant to take this out, didn't. What I will say is this. The amount that some of us are struggling, I think that some of us need to do more of that homework that's been assigned, that I gave you solutions to check yourself on. I will say this, and I want you to understand, I get it, the block sucks for AP, point blank period. Like, especially if you have multiple APs in a single semester, it's the worst design ever. I don't understand why people would continue to use it, yet here we are. we also have to be aware that we have an AP exam that's coming up, and I'm trying to find that balance, but I also need to need you to make sure you're staying on top of those things, because I can't control that for you. You stay on top of things though, we're gonna be good to go. Right now, we're about to get into what a random variable is, a discrete random variable, and how we even calculate mean and standard deviation. Some of these things we've actually already talked about, probability, etc. So first things first, I will say this, and Ms. Kowalski, you're gonna jump up here in a second to talk about these things. But what do we mean by discrete versus continuous? Give me an example of a discrete variable.
Discrete is like
Time.
number of kids.
Okay, so number of kids.
Oh, wait.
Sure.
Yeah, 100%, right?
I think I
Three and a half
used
kids.
another word.
So we got
Okay.
discrete.
I was listening to it.
What else do we have?
Continuous is like height.
So continuous is height.
Please don't take off my
Okay. Give me another discrete
At one point in
example.
life, I didn't doubt he has made one mistake.
Well, it's not just one.
I'm surprised he didn't say the same. Oh, is number of kids the only discrete thing we can do?
Number of teachers.
Number of teachers.
Bruh, there you go.
Number of something is the
Well-
will.
You can have half a teacher.
That one guy's here sometimes.
Yeah, you can have a
Count
That
one
one
teacher.
guy's here sometimes.
His name is Mr.
Colors.
What's his name?
Mr. Shots.
Zip codes, colors.
Sounds like a good.
Okay, let's go back though. I want to point this out. These right
Wait a
here
minute,
are
yeah.
not discrete. Why not?
It's categorical.
Yeah,
Okay.
they're not context.
So remember, zip codes and colors, those are categorical.
It's just
Discrete has to be what type of variable? Quantitative. Discrete and continuous have to be quantitative. So what do we mean by discrete?
Like you can't have like half
Count
an
it.
It's not.
Like it can't be like
Integers.
measured or, well.
So
Yeah, yeah.
it
can't be
typically,
can't
right,
be
typically it's gonna be integers.
Can't be interchange.
It cannot be in between. The best way to understand discrete is that it is not continuous. And I know it's gonna sound kind of whatever, but what I mean by that is this. So, if the only options for something are 1 or 2, and I can't get anything in between, that's a discrete variable. 2 or 3, but I can't get anything in between, it's discrete. It's discrete isolated points, okay? Usually something we can count. However, there are cases where maybe I can get a 1, a 1.5, a 2, a 2.5, a 3, a 3.5, but notice, am I getting anything in between the 1 and the 1.5?
No.
No. So,
It's like how you can have like an A plus or like an
That's a
A
great
or like
example.
an A minus.
yeah, but we might need to make that just kind of categorical, but similar ideas, yes. All right?
Yeah.
Yeah. But continuous, it's not just 1 or 2 that I can get any value in between 1 and 2. So, when we talk about height, you might report someone's height as 5 foot 8 inches, but does that mean it's exactly 5 foot 8?
No.
No, right? It really could be 5 feet 8.2 inches. We just reported it as 8 inches, right? Or it could be 8.213 inches, or 8.213, 5, 6, 7, 8, 9 inches, right? It's somewhere in that 8-inch range, okay? So if it's continuous, someone did mention, by the way, discrete, anything that we count is going to be discrete. If you measure, it's going to be continuous, okay? So discrete versus continuous. Now, those are not the only cases, but that's a good place to start. But when it can be on a continuum, that's when it's going to be continuous versus discrete. Okay? Ms. Kowalski, you ready to start this part? Okay, so this mathematic is part of the white sheets in the packet that I gave y'all while you were doing your DYU.
How many of y'all are an only child? 2?
Including no
Well,
step
Step,
siblings
half.
or half siblings.
Oh,
What if one of them like
So
Just
one.
no.
died?
Dang.
So we
Why
got
are you
it.
looking at me?
We all have.
That's sick and twisted.
That's, yeah, that's mean.
Okay. I don't know what he said. I don't want to.
It was,
What?
hush. How many of you have 2 siblings? Half?
Just do it. Sorry. That one.
Wait, two
Wait,
siblings?
you just said,
Shouldn't that be
you
a
said
zero?
one.
I mean, one
Yeah,
sibling.
how many have
I-
you
One sibling,
How
there are 2 children in your family.
That's, I meant 2 in your family, y'all.
2 children in your family.
More. He's not really my family. He lives in
Dang.
Sava.
But
Do you
he
have
is
the
a part of
same
your-
mother or father? don't even know what that is.
Oh my gosh.
I
Okay,
probably have like
1, 2,
7 siblings.
3, 4.
How many do you know of?
Dang.
How many have 3 in
Three
the
children
family?
in the
Like dead or
family.
alive? Like,
Yeah,
your choice, up to your discretion.
I told you.
How many have 3?
Family Bush. Family Tree.
She doesn't even know. Okay, we're gonna say.
Why did I know that?
4 from another class.
Yes. I collected data from my third block.
4.
So this is
5,
We're
6,
done there, right?
Is there anybody we have not gotten data from yet?
7,
what
8.
is already?
So we got everybody's
Who has
data?
8 siblings?
Why is
Some
Somebody-
people do.
No, wait, what's going on?
Why?
My dad
Wait,
had
1,
10.
5, 4.
There were 10 of them.
Why aren't those numbers up there?
What does that mean?
Yeah, I don't get it.
There's just a bunch of like.
That's how many
Let's see that.
siblings there are, or how many
It
children in
needs
a
to be
family.
organized.
Yeah,
Mr. Kinney erased it. It was organized.
There's
Where's the
just like
holes?
continuous and measure all that going through it.
Yeah, where's the
Oh,
Oh, there's
Three
data, there's data
numbers.
from the other class, that's why.
Get rid of it, get rid of it.
Okay.
Yeah. We should make like 2 separate data sets.
Yeah, cause.
No.
No.
I collected this
We are only
data
9
to
people.
give us more data, get off us, and
Well,
let's learn
We should
something.
combine after.
Oh,
We
okay,
combine
okay, so I
after.
understand now. So the 8 is like there's
I
8
understand
people
now.
in the combined classes. I understand.
Okay,
Yeah.
that makes
One
way
only.
more
There are
sense
8
now.
people between the 2 classes that had a total of 3 children in the family.
There's.
There's only one person who's the only child?
I mean, it should have been me, but like, y'all are extra.
That's looking crazy.
How are we extra?
I didn't know my brother until last year.
Yeah, but he's like.
So statistics.
That's
Give
looking
him.
You guys should trust me
There's
now.
about
Well, hold on.
34.
Because they need to calculate the probability.
Oh, yeah.
How
Oh, I was
many?
actually put in the numbers.
What's all
Okay.
total?
I couldn't
So,
erase them.
guys, we
Count
need
it.
y'all to complete the table, and we need you to work through what, number 6. They're gonna work through it, and then we're gonna do it.
What do you do?
Is anybody doing third?
Can we write it as fractions?
Hmm?
Can we write the probability as fractions?
Let's do fraction and decimal, please. Good question,
Just do
though.
decimal.
Sure. I was letting him work on all of that.
Yeah.
But, go ahead and tell us about that part.
What are you looking at?
All right. Is 5.7167 a possible value for x?
0.0.
Why?
It's discrete.
Because
This
it's
is
discrete.
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 Variable.
You can't have
Let's turn up buzzwords.
5.716.
I'm gonna talk about something in a second, but that needs you to pay attention to. But
You
you're
can't have
skipping the zeros.
5.7167 kids. Exactly. Cannot. Oh.
Making sounds.
Sorry.
I want to caution something just because I just saw this. When you are, so first off, does anyone know what we're going to call this table right here?
Probability table.
Close.
A P table.
No, why don't you look at that proficiency scale, see if there's anything there in the foundational piece.
You have to cuss this.
No, maybe eventually.
Probability
It's
distribution.
called a probability distribution. Why is it called a probability distribution?
Distribution.
Oh my gosh.
Yeah, how do we know it's a probability of a distribution, or distribution of a probability?
Because
makes
it's
it
probability. Oh.
And then
There's,
there's a bunch of.
so there's a probability, but it's not just because there's probability.
Because it adds up to 1.
Ooh, it's a valid probability distribution because of that. I was going to come back to that in a second, but it's also because of this. What is this right here?
Oh,
A variable? What?
Not just a variable,
Random.
a random variable.
Wait, that'd be like.
That's what we call it. It's a discrete random variable. We're going to do probability with it. It's a discrete random variable. So we can do calculations with it, things like that. But it is a variable. The number of children in that family changes, right? It is a probability distribution because not only does it have a random variable, it has what with that random variable? The probability.
Oh, yeah.
So a probability
Why are you
distribution,
looking like that?
especially for a discrete one, and I will say this, you're only going to have tables with discrete ones. You cannot have a table with a continuous one. But for discrete, you're going to have that. Now, I want to caution though, I'm going to talk about what you said in a second, Brady, because I saw and please understand, this is not me getting on you, it's learning from this, saw someone writing this earlier, and we should know that these could not possibly be the probabilities. But this is an important thing to learn from. Why could these not be the probabilities?
I already added up to over one.
Yeah.
Remember, the sum of all probabilities for the entire sample space is one.
No.
So slow down and pay attention to that. Pay attention to those zeros. Don't skip them. Right? That already would be more than one. Right? We can. The sum of all the probabilities is one. Sprig, did you have a question?
Is it, what is it if like,
Question you, thank you.
like it's like a range, like if the whole section was like 1, 2, 3 children and then like 4 to 6 children, like is that categorical?
It would still be a. Once you make it into groups like that, yes, it would become categorical.
Alright,
So we're not going to do that.
alright.
Now, we can also, I will say this, let me think on it more before I
Can you do
definitively
a
say it that way.
probability table with categorical?
Well, you can do a relative frequency table, but it wouldn't be, yeah, you could do probability tables with it too.
Alright,
But it'd be equivalent to a relative frequency table. Do notice these are the same as the relative frequencies.
yeah.
Okay? I don't think this question comes up later, so I do want to ask this. So you already said, is 5.7167 a possible value for x? And y'all said? No, because x is discrete, you can't have that many kids. Is that a possibility for an average number of kids?
Yes.
Yeah.
And so I need y'all to hear me clearly on this. And it's in your, it's gonna be one of the, because I was reading through the book, I don't know if you noticed it, but this is an important point on the AP exam. There are so many times on discrete random variables like this, that on the AP exam, students take the average that they calculate, and they're like, well, you can't have 2.76 children, so I'm just gonna say it's 3 children. But if it's an average, could a family on average have 2.76 children?
Yes.
Or you could
Do
say they
not-
have 2 or 3 children.
No, don't round your averages.
Definitely not.
Or don't round your averages that much. Round, like, do not round it to integers, just because it's discrete. You need a true average.
What if you have typical?
Well, you could talk about a median, but if they ask you for the mean, you have to report a mean, which they oftentimes will ask you for a mean. Okay?
Alright, so calculate and interpret probability x is greater than or equal to 3. Did anybody do this yet?
Yeah.
0.363636.
What? How did you get that?
Zero.
That's what I
I
had.
got 0.
How did you get it? How did you get 3 6
I
just
just
How did
added-
you got the opposite?
I just added 4 plus 2 plus 1
Okay, Sprig, how did you get yours?
I got 0.
Wait, no, I should have added the 8.
all the time.
I missed the 8.
Yeah, 'cause
Sorry
it's-
about
Greater than or equal to 3, so you take all of
that.
it.
I bet you guys.
So what do we get?
It's 0.72 repeating.
0.72 repeating, beautiful. Awesome, amazing.
Gary?
Alright. So one thing I do want to point out is this. So Michael said that he took the 8, 4, 2, 1, 1. Is that the only way to get that probability?
You can, no, you could add up the.
Yeah.
You could also add up the probabilities themselves. Now I will say, which one's going to be easier in this problem?
That one.
Because all of those are repeating decimals, it's going to be easier to just add those integers up and divide it by the 22. But be aware, you can do either. Huh?
Get there yet?
I hadn't talked about that yet, but go for it.
Oh,
So if you're using the frequency, that's the easy way. But also,
another way you can do it is the probability that x is greater than or equal to 3 is the same thing as 1 minus what?
2 or less.
Yeah, is less than or equal to 2. Right? If you want to swap it, take your 2 and lower, or isn't it just actually less than 3 is how it's
what's the
supposed to be?
difference?
Or discrete, there's
Or
not,
it's
but
not
continuous
equally-
will be.
He's already going to tangent about that.
Well, we will go into that later, but what is the difference with discrete between these two statements?
There's,
It's equal to or less than 2. Wait,
Because they're discrete, is there a difference?
No, there's not.
Less than 3 would just be 1 and 2, right?
Yeah.
Less than or equal to 2.
Like, we just-
Continuous is where it does matter. There's something I was gonna say with that.
What
Because
is-
there's a space between 2 and 3.
Yeah, it's because it's discrete, there's that gap between there. Yeah.
So how does continuous make a difference?
Because there's
Oh,
literally
'cause
stuff in
you
that
can-
You'll
you
space.
can
miss
have,
the
like,
values in between
2.9,
2 and 3,
But then
yeah.
you can only have 2.
So you've actually already seen a continuous random variable.
Whoa.
Anytime you deal with a normal distribution, you're talking about a continuous random variable, right? And so there's a huge difference between 1 standard deviation below and 2 standard deviations below, right?
Yes.
So you can't ignore all this. So saying this versus, or less than or equal to 1 versus less than 1, less than or equal to 2, those are radically different because it's missing all of that space in between.
Yeah.
Does that make sense?
Mhm.
So this is what I was gonna say. I need y'all to pay very careful attention to this because this is something that tripped me up. It's in the book so that you can refer to it. Yes, I did ask about books, Serena.
It's not
Oh, yeah, it's
happening
February.
yet.
It's happening.
It's not happening.
No.
I don't know when it's
It's really
happening.
tough because
halfway
we can wait
through.
before these.
Okay,
We're
really
already
quickly.
on half three.
I just want to point this out. We always use, and I did not pay attention to this for the longest time, and it made it harder for me to read these probabilities. What we have right here is going to always be my continuous random variable, and we use capital letters for our random variables. We use capital letters to indicate those random variables. But if you are not comfortable and don't love those letters, what could we put here instead of X? The number of children is less than 3, right? Like you can write out those statements. But this is also why it's super important that you define any random variable you ever deal with. So X is the number of children. So instead of reading it as probability that X is less than 3, 1 minus the probability that the number of children is less than 3. Define your variable and stay in that context. Yes, Rick?
If it's discrete on a histogram, do the columns still touch?
Yes, so that was something, actually that's what I was going to pull up a second ago from their notes. There's 2 different ways, to do that histogram. And I'm curious the way that they were recommending it. No, that's
I
the
don't
wrong.
think you're 45.
Michael, my mom
I
is
was looking, okay, no, I was looking at that 45 over there.
Yeah,
And I
sure.
said 45.
She's never-
Just quit, just say you screwed up, move on.
That's what I was trying to say.
Okay, that's exactly what
Oh
I
my
was
gosh.
thinking. Okay, so
This guy.
Spree was asking a good question, and I'll just show it how they did it. So they have different data than us, which is why we obviously are not using theirs. So notice right here, when we have this information that we need.
Yeah.
Yes. Everyone should have created a histogram. So when
Right.
you have discrete random variables, and it's not continuous, you actually center the bar at that number, typically. So for us, and so I think we just hadn't seen anything like that. And you don't have to, but I probably would here because it makes things make more sense. First off, what scale did y'all use on the y-axis?
I just
I
went up by,
did-
I went up by 0.09.
I did 0.2 and then 0.4 and then 0.6 and then 0.8.
What was the highest probability we had?
The highest was 0.036.
So I would just go by 0.1. At the highest. Maybe even 0.05.
I'll just do 0.09 because
This is 0.2.
That's true, that could work.
they're nice probabilities.
So you can use any scale you want. 0.09 does work probably pretty well. But the big thing I'll say is this. You will want to, because it's discrete, what you're going to do is you typically want to, whoops, that's 0.045 repeating. You'll want to center it at that number.
Oh.
Okay, so that's, I should have thought about that. I think we only looked at continuous random variables before with our histograms, but we're going to want to center them that way.
I'm gonna erase everything. I'm just gonna like use a whiteout, come on. Maybe?
It's gonna be higher than that, right? Because it's 0.227.
227? Oh, because this is just a 0.3.
Yeah.
That is so crooked. That is, oh,
Okay.
you draw a straight
Now-
line. These
Okay.
are
What I
not
would, so Serena, what I would say instead of completely redoing it,
I just see some.
I would just say, write a note to yourself that when it's a discrete histogram, center your bars at the values.
I already did it.
Okay. So just make a note of that to yourself to learn from that for the future.
I don't like this scale. Yeah?
I would put higher, it's a little bit closer to 0.4, isn't it? Because 0.36 repeating.
I have it like that.
See,
Oh,
if you wanna
my
put
line
0.09,
went down. This one would be an issue.
Yeah,
You
but
could
then
do
we have to
0.09.
by 0.0.
My bad. You're right, 0.09 would
Four.
probably be good, it's just an odd scale.
0.18 repeating.
Repeating.
What about mine?
That's like
220 seconds.
Wait, you look at the repeat, you're not getting it.
or 4. No?
Is that valid?
No, okay.
Is that something
Three,
that
five,
means something to most people though?
0.09 repeating.
Most people, that does not mean a single thing to most people who look at that graph. No one's gonna be like, 20 seconds? I know what that
Six.
number means.
6 is 0.045.
Listen, if you wanna do it, you can. Typically, we do decimals
7's the
on a
same?
scale like that.
Yes.
Oh. It's crooked.
So, Sprig, were you the one that was asking, do we let the bars touch?
Yeah.
This is how we still have our histogram touching when it's discrete random variables like that,
Wait, which one is it?
because it's not a bin.
Where, what's it called whenever, like, you stack them on top of each other and they equal 100 on the top?
Segmented bar chart?
Yeah. That's what I think about that.
If they're discrete, so you could still have
Segmented bar chart.
What kind
stuff in between though, right? It would just be like, what if that was like 1 and 3, so there'd be like.
So in that case, yes, but if you're doing discrete, especially like sequential integers, you definitely wanna do it like that. But typically when they're yes, when they're integers like that, individual integers, so if you do 1 and 2 together, you're grouping stuff together. I guess the best way to say it is, if you're not really dealing with bins, or the bin is 1, then you're gonna wanna center the bar. Maybe that's a more clean way to say it.
Shape, what was our shape of our distribution? A little skewed right. You're a little skewed right?
Ooh, I need more than just that, you're in an AP stats class.
Oh my gosh.
The distribution of the amount of kids within a household is UNMO.
And skewed to the right.
So, great description of the shape, but we need to always include what?
Then
Spread.
center.
Wasn't
No,
that?
Context.
What the context?
Oh.
We could find a measure of center
I
here.
was like,
I
I
tried
was
to
thinking,
What measure of center could we report?
Median?
Median.
The median?
Yep.
How do we know what that median is?
It looks to be
What-
around
We know how many
3
values there
Do
are.
11 divided by 2, then count to where that is.
Oh, yeah.
So wherever.
11 or 22?
22.
Yeah, 22.
Oh my gosh, it's 22.
Yeah, so you have 11 on each side.
Yeah. So where's that gonna be?
It's called because
Would it
it's
be
all
50?
decimals.
well, no.
Um,
One?
What?
No, it's not gonna be
Between 2 and
Like
3.
3
Why
point
not?
something.
Yeah,
Three.
And 3.
Yeah.
Three.
It's
Yeah,
in
The
it's
third
like-
bin?
It's in the third bit, yeah.
It's like 3.5-ish.
What do you think, Ms. Kowalski?
8.
I mean, it's
It has to be in
For the
3
median.
Does
because
it add up to?
4 to 7
Median?
is 8.
6.
Yeah.
Median is just 3
7,
because like,
8,
if
9,
they're in a bin
11,
and it's this 3, then it's just 3.
It's
Yeah,
3,
yeah,
yeah. So the median, guys, is 3, because what I want you to think about, we didn't write it this way, but what this is really saying is,
3.5.
this person, there's one person with one sibling, there's 5 people with, where there are 2 children, I should say. There's 3 or 8 with 3, right? So that's how many data values we have. So our median is 3. You're not gonna have a decimal median in that case. It'd be very rare. Okay? The other thing I would have just said is, remember, what does a median do? It separates it into
Top 50.
top 50 and bottom 50, right?
Yeah.
I mean, What was 8 out of 22 again? 0.36 repeating?
Yes.
And that's 0.227 repeating. That's over 50% right there, so it had to be there. Make sure, but I will say this, sorry, I meant to say this earlier. Yes, you can find the median. You're dealing with probability distributions. We usually want the mean. We'll show you how to get there soon. Do I have the remote?
Yeah, I don't have.
Oh, I have the remote.
Yeah.
Got it.
Alright.
I'm surprised it's not broken.
Same, to be honest.
Average of the x values is 4.5 children. Does this value give the average number of children in the families of students in this class? If yes, explain. If not, why not?
No, because it's not resistant to like potential outliers around the 8 area, and we're
What?
As
Not on
the-
the 8.
not the 8, like the
Why do we care
7.
what the outline?
Oh, like, are y'all talking about that?
So,
Like the numbers up there?
yeah,
This-
so the 1, 2, 3, 4, 5, 6, 7, 8, that comes from the possible number of siblings. The average of 1, 2, 3, 4, 5, 6, 7, 8 is 4.5 children. So is the average number of children 4.5?
No,
Yeah.
it is less than that.
That's
How do you
like
know?
if all
Well,
the children
big.
are equally likely.
Yeah,
Yeah, it's,
and they're not equally likely because it's
skewed,
harder to have
But they
more
are
children.
I wrote
No, it's
down
not
my
equally likely
thingy,
because the more children you have, the more complications there are.
What are you talking?
And just in
I think
today's
this is
world,
just about
people have
math.
less kids.
Yeah.
They're too
That's
fancy,
true,
bruh.
but also.
Yeah.
No, what's it?
Does any, okay,
Oh,
why are we saying no?
because,
Because,
but you only get each bit like once, right?
did we get 3 children only once?
No.
No,
Did we get 4 children only once? So did we get each one only once?
no, so they're not
No.
equally likely.
We also didn't get 8.
That isn't the correct distribution of probability. Boom.
well, also.
What did you wait on?
Oh, you would have to wait it, so that'd be like 10,000.
Say that one more time. You have to what?
You have to wait it.
You
Yes,
have
weighted
to
average.
weighted
8 times
average.
3, 4 times 4,
The-
5
The fact that there are 8 people who have 3 children means that our mean is probably gonna be close to what? 3, right? That's weightier than everything else. Do we know how to do a weighted average in here, perchance?
I'm just gonna say though, just to see.
Yeah.
You can
Like
do it.
you
You
do
do
the
it.
probability
Yeah.
times the
Yeah.
x value.
Remember you.
Oh, we'll get to that in a
multiply,
second.
like, this
How do you know that?
By the value. So, you multiply
What does that?
So how would we weight this? Yeah, I mean,
Is that fine?
we need to
Like,
weight
yeah.
You're insinuating.
number of x values. So how,
He's also.
oh yeah, this is the part where I was gonna come up, wasn't it?
Yeah, 'cause
Okay.
I don't know. I just-
Yeah.
I don't care about my.
Okay, so first, I wanna talk about this really quickly. So we said that we need to do a weighted average, right?
Yeah.
So I'm gonna connect a couple of things with this. So first things first, how many times did we get an only child?
Once.
Once, right? How many times did we get only having one sibling, so 2 children? 5 times? So really, that's 2 plus 2 plus 2, dot, dot, dot. How could I do that more easily?
2 times 5.
2 times 5. How many times did we get 3 children? So how could I rewrite that? How many times did we get 4 children?
4,
So 4 times 4,
2,
5 times 2, and
6.
6 times 2. So this is the idea of weighting them by accounting for the fact that there are 5
Not
2s.
six.
Why is it
It's 6 and then 7.
Just
Oh,
the
thank
six.
you.
7.
Yeah.
Man, why'd y'all lie to me? Okay,
Why
then-
not just put 6?
Huh?
Why not just put 6? 6 times 1 is 6. I'm just curious.
what are you talking about?
Why not just put plus 6 instead of plus?
Because I'm trying, I really should have done 1 times 1 here, to show like how many 1s we have, how many 2s we have, how many 3s. It is equivalent, yes, but I'm showing how many 6s we have, okay? And I'll show you another reason why in a second. Now, the reality is we have how many total people?
22.
So that's how many total children we have, sorry, that's how many total children we have for how many families? Divided by 22 families, according to that data, right?
74 children.
Okay? So 74 children, we're gonna divide by 22, we're gonna get there in a second, but here's a more important thing to help us learn the statistics behind this. So what I'm gonna do is, did y'all know you can actually distribute division? Like I know we always distribute multiplication, but we can also distribute division.
What do you mean by that?
So, 50 plus 125 divided by 5. Yeah, I could add it and then divide by 5, but I could rewrite this as 50 divided by 5 plus 125 divided by 5. I just distributed that division by 5. That's it, okay? I'm going to use that property here. So I'm going to get 1 times 1 22nd plus 2 times 5 22nds plus 3 times 8 22nds plus 4 times 4 22nds
Oh my god.
plus 5 times 2 22nds plus 6 times 1 22nd plus 7 times 1 22nd.
I feel like that's more difficult than typing to your calculator.
You know, maybe I'm about to connect it to using the calculator though.
Oh my god.
Maybe. Hey Peter, what did you say earlier about doing that weighted average?
Probability times x value.
So you mean this probability times just the value? So doing this weighted average idea up here, we can simplify it by just taking the value. So please notice, we use x for the random variable, we use lowercase x for the value times the probability of that value. The value times the probability of that value.
Is this on our thing?
What? What could it be on? What is it on?
The thing?
The thing? What's the thing?
The formula.
The formula sheet. Oh my gosh, maybe it is.
Bro,
Okay, so at the top up
Has it right there.
okay, so at the top up here I see descriptive statistics. That's not useful.
Bro, this is.
Oh, there's probability. Does anyone see anything that's, I don't know, x times the probability of x maybe?
Yeah.
Oh yeah, right here, right next to
Discrete
random variable. Huh?
What is that saying?
What?
Exactly. That does
Just,
not look like we just did.
That's
So-
What is that thing? What is that?
It's a 6.
It's the sum, the sigma, the sum of x times the probability of x.
It just looks weird because it's like not right here.
What?
It just looks weird.
Oh.
because it's fully pointed.
So, right here, okay? Well, so here's what it is. Notice I did x1 and probability of x1, x2, probability of x2, and I'm adding all these things. So they use x sub I times the probability of x sub I to indicate the first goes with the first, the second with the second, third with the third. Now, what I want us to note in the last couple minutes that we have, so this is the average of x. Notice we always use mu when we talk about probability distributions, okay? You will oftentimes also see this written as E of x. Because what is an average? An average is just what we expect to see. So E of x for the expected value of x. That's cute, Brayden. So the mean or the average is the expected value of x. But I want us to see right here that it is in the probability distribution with that discrete random variable. Tomorrow I'll show you how to use the calculator to actually calculate what it is.
It's not appropriate.
It is not appropriate at all. Okay, we are going to pick up tomorrow. Hey guys, tomorrow we're going to move quick because we got to finish this lesson and do at least 2 more. We'll figure it out.
I kept on seeing him pick his nose, so I kind of. So what is our project gonna be on?
Maybe it's not, we can't add standard deviation.
Oh, we gotta find like.
That's what I'm really
Okay. So once we all have one, once we all like.
Oh, we didn't have to do like.
Okay, you like good stuff. I like Dr. House. Whatever.
Oh, you can
You
ask
like
me
Dr. House?
how.
Okay. That's off the drawing board.
That's the exact experience.
Oh.
Great, they got on that.
I did it on
But
Saturday.
zombies.
So that might be fun.
Yeah.
Yeah.
We're doing fun play.
Yeah, response bias.
Does we cliche do it?
No,
Trying to finish
cliche
this
for
thing
a
as much
stats
as
project?
possible. My guess is
Yeah.
Well, I guess
we
we
work
can-
How many people in the
with
South
guessing.
believe in
bio and random variables.
I mean, I feel like we
Yeah,
get
well,
more
yeah,
something
yeah.
more like that.
Or this,
Do you believe in
take
it?
more
Passive.
Do you believe in Bigfoot?
But like maybe we could vary like
I lied.
I-
the
So
levels.
that's 1 out of 3. That could be our
Okay.
whole data.
Whatever.
No, I'm just saying.
Like, we can't say all
Maybe-
stuff, we
maybe
have to say something right,
that's
because
right.
like, how much?
In our district.
Maybe-
Yeah, we're gonna, in our
Or maybe you do
school-
like
Oh my gosh, I have to like ask everyone.
you prove the prompt a lot.
I'll do it. I got no
I had the
shame.
proper
Oh, yeah, you got
theory
it.
project
Let's ask-
professor.
so our
teacher-
His name was Dr. Swiggers, and literally he was known as being.
Very
What
very
idea
awesome.
for our
awesome.
project?
What's your project?
Come here, we can't
All
tell
right.
our sauce to anyone else.
Okay, let me pause the camera.
Sure.
Somehow all mine